Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yakub. So we are starting with the P3 live stream, and this is day 2, and it's 11:04 a.m. and we are focusing on few things that we discussed last time. That the topics that we need to discuss are these: that is complex numbers, vectors, numerical solution, a bit of trig because a lot of trig was discussed in differentiation integration, and a bit of binomial expansion. So let's first get started with complex numbers. So now when we talk about complex numbers, there are three main aspects of complex number. There is the algebra part, there is the trigonometric part, there is the loci part. When we talk about algebra, it is about polynomials, quadratic, cubic, everything. It is about add, subtract, multiply, divide, the concept of conjugate, and what else is there? Division is already taken care of, something about square roots. And I think the most important thing over here is this polynomials. Yes, based upon polynomials, there is also simultaneous equations. And the same thing with polynomial, that is about solving a quadratic equation, solving a cubic equation. So that's all about polynomial. It's about remainder factor theorem. It's about solving inequality, number of roots, something like that. So the most important thing over here is polynomials. When we talk about trigonometry, this is called the modulus argument form. This is conversion from the regular form, that is the Cartesian form, into the mod arg form, and vice versa. The graph is now called the Argand diagram, the real axis, the imaginary axis, Argand diagram. We can talk about basic vectors. We can talk about geometry. We can talk about trigonometry. Sometimes circle properties are used. Sometimes triangle properties are used. And in trigonometry, sine, cos, tan, sine rule, cosine rule, Pythagoras, all these things are there. And there are special rules for multiplication, special rule for division, special rule for power. Transformation, that is also there. And I would advise you strictly to watch 2025, May, June, October, November, and I think also February. There are 4 videos that I made, and they are related with what we are doing now, and also related to these past paper questions. So they are worthwhile. So now check them out. That is very necessary. Then we talk about loci. Loci is about drawing. Loci is about shading. It's about greatest least value. It's again about vectors, geometry, trigonometry, circle properties, triangle properties. All these things are also over here. And sometimes they give us separate questions. Sometimes it's a combination. Maybe it's about algebra and trig. Maybe it's about trig and loci. Maybe it's about algebra and loci. So it's a combination, or it can be separate questions. So complex numbers requires a lot of attention. Now, what I can do is that let me go to the exam report of complex numbers. And let me read out the exam report in general also, and also with the perspective of complex numbers. So now over here, the exam reports are related with November 2025. And I'll read some of them, especially the complex number part. First of all, there are some key messages that we need to take care of. And those key messages are related with presentation of solution. Always talked about it. That's how I do my working. Use mathematical terminology accurately. Applies to all aspects of work, but particularly the use of brackets, the mathematical operation. Essential brackets are often left out. That's not a good thing, leading to serious errors early in a solution. When the brackets are there, care needs to be taken over the signs when the brackets are removed. So the wording that I use is that brackets are for free. Use them excessively and at least where necessary. Now, further on, it says, if an error is made when working, cross it out and write it. Error is made, cross it out and rewrite it. Writing over an existing solution usually leads to illegible working, which is difficult to mark accurately. And the same thing goes for like pencil and pen combination. Never do that. This also applies to drafting a solution in pencil. So whatever I was talking about, that's written over here, and then writing over it in ink. Not possible to work out what was intended. And of course, there are scanning issues also. Do not expect every question to be solvable in the same way as a similar question on a previous paper. Now, this is very nice. Keep an open mind and think about the relevant methods. So, yani out of box thinking you need to have. So, out of box thinking, that is what differentiates an A star versus an A or A versus a B. So, that is how that discrimination is made. And then it says, be careful, be mindful of the messages about common errors in past papers. Do not make up new rules of algebra, logarithm, trigonometry, and look out for basic forms such as improper fractions and partial fraction. Show sufficient working to make the method clear. Sufficient working, show all working, and detailed. If an answer is worth more than 1 mark, then simply writing down an answer from the calculator will not be sufficient. And also, they have used the terminology in the past. Unsupported answer from a calculator will gain no marks. So very, very important, which you have seen over here. Okay, let me bookmark it. Now, candidates found this as a challenging paper, with many gaining fewer than 10 marks and very few scoring more than 60. There were frequent unforced arithmetic errors, and many responses shows errors due to incorrect presentation. Omission of bracket was common, and very few candidates recovered from this. And let me talk about some question related with complex numbers. So this is fx, tx. This is vectors. So which one is the complex number 1? Partial fractions. Okay, I think this is the one. Now it says the crucial starting point was to recognize that the real part of the number represented by p is equal to 2. And after this, most successful method was to use the equation of the circle and substitute x is equals to 2. So again, I will recommend you to watch that complex number videos. And this is about which particular paper? This is, I think, variant 32. So this is October, November 2025, variant 32. Watch this thing. Over here, equation of circle from P1, that knowledge was also used. And because of this, this led to a quadratic in Y, where one of the solutions led to the correct point P. The alternative method seen in responses was using Pythagoras theorem to obtain the Y coordinate of P. Some candidates overlook the request for the answer to be in the form x plus iy. So now over here, let me re-emphasize this. Read the question, reread, and read it once you are done with the question so that you know exactly what are they asking. Then it was about some angle or something. The majority of responses identified the correct point to work on. The simplest method was to split the required angle into two parts. Many candidates found the angle tan inverse 1/3, but finding the other part proved to be more difficult. A few responses were successful in finding the equation of tangent to the circle, and so on. So basically, this was about geometry. So a lot of circle property, that is radius is perpendicular to tangent at the point of contact. You create a triangle. Then maybe the x coordinate is given, y coordinate is given, find the length, find this angle theta, this kind of thing. So that is necessary. So now that was just a brief sneak preview of this. Let's start with complex number. So in complex number, we get started with this idea that z is x plus iy. That is the Cartesian form, the algebraic form, the normal form. The real part is x, imaginary part is y. I square is -1. So therefore, square root of -1 is I. That is where we get started. So a complex number starts with the basic idea of square root of a negative number. When we add two complex numbers, the real part gets added to the real part. The imaginary part gets added to the imaginary part. So real, real, imaginary, imaginary. The same thing goes with subtraction. Multiplication, this is like just like algebra. So this is like a plus b, c plus d. You multiply it out. And we should know that I square is -1. So wherever we have I into I, that's I square. So this becomes -1. This now becomes a real number. So real with real, imaginary with imaginary. Conjugate. We change the sign of the imaginary part. When you multiply a complex number by its conjugate, a plus bi, a minus bi. If this was normal algebra, a plus b into a minus b would be a square minus b square. But because of the I square, this becomes a square plus b square. It becomes a real number. Division. How do we get the division thing right? So we multiply and divide by conjugate of denominator. This is rationalization, just like what we do with surds. So over here, this rationalization is for complex number. So this is the basic idea. Then this is a standalone question. It just comes standalone. As such, nothing to do with the other parts, except there is one geometrical aspect that I'll talk about. Find square root of 5 plus 12i. So square root of 5 plus 12i, that is a plus bi. The constants a and b are real. This is also written in the question itself. Square both sides, square root disappears. You get a plus bi whole square. You get a square plus 2abi plus b square I square. I square is -1. So now this is the real part. This is the imaginary part. Now, if two complex numbers are equal, the real should equal the real. The imaginary should equal the imaginary. You get two equations. You solve it simultaneously. From this non-linear equation, make a variable the subject, plug in the other one, simplify, get a disguised quadratic equation. Now, m is +9, m is -5. We will reject it. Why? Because the answers would be unreal. So let me write over here, why are we rejecting it? Because the coefficients are real, and this will give me unreal values. So a square is 9. Therefore, a is -3, a is +3, b is 6 over a. So if a is -3, b comes out to be -2. If a is +3, b comes out to be +2. Write the final answer as it is. This is x plus iy. This is x plus iy. Now, what is the geometrical relationship between the two square roots? They are 180-degree rotation about origin. A point such as xy becomes -x, -y, coordinate changes sign. So let me write the word over here, only coordinate changes sign. There is no flipping, as in a 90-degree rotation, as in a 90-degree rotation clockwise or anti-clockwise. So square roots are 180 degrees apart from each other in terms of rotation. Then we talk about the concept of quadratics and complex roots. So now we have this thing, which is there is an equation, and b squared minus 4ac is coming out to be negative. That means the roots are imaginary. The roots are complex. So square root of a negative 16, that is 4i plus minus is already written over there. So we simplify, we get these two. Since the sign of the imaginary changes, they are conjugates of one another. So now over here, also remember this thing. That is the coefficients of the quadratic terms, of the algebraic terms, are real numbers. If they are real numbers, then we will get the roots as x plus iy and x minus iy. That is a hard and fast rule. If one of them is imaginary or two of them are imaginary, then this thing does not hold true. Complex roots are conjugates. Graph lies above the x-axis because the coefficient of x squared is positive. Now this thing, if we have the roots, if this is the factorized form, we equal it to 0, we get the roots. If these two are the roots of the equation, what we can do is that this is q, this is r. So now we have two roots over here. Just plug it in over there, but multiply in a very tactical manner. So x minus 3 plus 4i, x minus 3 minus 4i. Open up the bracket, you get 1, 2, 3 terms, 1, 2, 3 terms. So if you multiply without thinking, you will get the things very lengthy. But if you use your brain, which you should, so this is the real part, this is the imaginary part, this is the real part, this is the imaginary part. So this is real minus imaginary, real plus imaginary, like the conjugate thing. So a plus bi, a minus bi, that's a square plus b square. So what is a over here? A is the blue one. So a is the blue one, that is over here. This is a square. And this is 4i. Just talk about the coefficient, that is 4, that is square. The I square is already taken care of. So this I into this I and this plus and minus, that's already taken care of. So this is like the same thing, the conjugate thing. So now we get this thing, that is the quadratic equation. The same thing goes for cubic. The basic rule for solving a cubic equation is find the first root by trial and error. X minus that value is a linear factor. Find the other roots by algebraic division. So this is taught in polynomial. This was you need to check the live stream part 1 if someone wants to have a good look of the topics that were done earlier. We did differentiation, we did integration, we did polynomials, we talked about modulus, we talked about logs and trigonometry from the perspective of differentiation and integration. So now when we divide, this is what we are getting. So now this one, when we apply the quadratic formula, first of all, the square root has a negative sign. That is why it is complex root. So definitely it is not factorizable. Now we get this answer. We get two answers. They are complex conjugates of one another. This is minus half minus root 3 over 2i. This is minus half plus root 3 over 2i. So break it down. Complex conjugate roots always. That's how the graph will look like. One real root, positive coefficient of x cube. It will start with top right and go till bottom left. The same thing over here, examination type question. The roots are negative 1, 1 plus 2i, 1 minus 2i. Find the values of the unknown constants. So first of all, x minus minus 1, that is x plus 1. This is x minus bracket 1 plus 2i. X minus bracket 1 minus 2i. So just what we read about the use of brackets, that is how I comfortably use the brackets. Now this is x minus 1, this is 2i, this is x minus 1, this is 2i, negative sign, positive sign. So now we have this thing. This is x minus 1 whole square, and this is 2 whole square. I square is already taken care of. Okay. So now we have this quadratic on the inside. Simplify it, multiply with x plus 1. This is the cubic equation that you have. A is the coefficient of x cubed, B is the coefficient of x squared, C is the coefficient of x, D is the constant term. So A, B, C, D, that's how these constants are found. Uh, Something like this. Now they write these things so that you don't plug in the calculator and get the roots. So that is why the use of calculator is not permitted. For basic calculation, of course, you can use the calculator. No one is stopping you. But just an answer based on calculator, that is not acceptable at all. Now that's a polynomial. This is p of z. Rather than function of z, they write p. I don't know. And this is power 4, power 2, power 1, power 0. What is missing? The 0x cube is missing. So keep that in mind. The complex number minus 1 plus I is denoted by u. Showing your working, verify that u is the root of the equation, factor theorem. Find the other three roots of the equation. So minus 1 minus I, that would be the second root. Okay. And then you have to find two more roots. So first of all, when I write this out, let me take common from these two. So I'm taking z squared common. And inside the bracket, this is z squared plus 3. So z squared minus 1 plus I whole square, that comes out to be negative 2i. So this is negative 2i over here. This thing also is negative 2i. So now over here, this is z squared, this is z squared, and I am plugging this thing over here. Let me just remove this thing for right now. Okay, so basically, wherever there is z, let me plug in minus 1 plus I, but do a little bit simplification first, rather than putting everything over there and creating a mess. So minus 1 plus I whole square is this thing. So this is negative 2i, this is negative 2i like this, plus 3 is there. And then you have to open up the bracket. So opening up the bracket with this, opening up the bracket with this, taking care of this plus sign, taking these two, multiplying with this, and look at all the working, it should come out to be 0. Yes, mistakes do occur in this. You have to be very, very careful. That's all I can say. Something, the same question now carrying on. So now z minus this root, z minus this root. So if they are using z, you should use z. If they are using x, you should use x. So therefore, this is the same thing over here. So this is z plus 1 whole square, and this is I, the coefficient is 1, that is 1 square, plus sign is there in the middle. So this is the quadratic part. Then carry out long division. So now over here, since the z cube was missing, I wrote it with a 0 coefficient. So this is the power 4 equation. This is the quadratic equation, 1 step, 2 step, 3 steps. That's a normal standard. And you get this thing as 0. That means this is the other quadratic factor. So z squared minus 2z plus 5. First, let me check the discriminant. It's coming out to be negative. That means it also has complex roots. So that is how you get two more roots. So there are two pair of complex conjugate roots. So roots will always occur in conjugate pairs. So complex roots, they will always occur as conjugate pairs. That is the thing over here. Now let's look at this, something to do with the Argand diagram and so on. Now, some of the parts, since this was taught in terms of topic, so this one is done over here. These three are done later on. So you will have a question split into two parts. Of course, you're not going to do in the exam. This was done while I was teaching it. So now it says showing all your working without using a calculator, solve the equation. Give your answer in the form x plus iy, where x and y are real and exact. So now exact, it can be asking in some instance, maybe it won't ask, but this thing is always there, where x and y are real. The coefficients of the complex number, they have to be real. The same terminology they are using in the square root thing. So now it says sketch an Argand diagram. My bad, that's not the one. So we're just focusing on this part one. So the coefficient of A is 1, the coefficient of Z is this much, and this thing is there. A is the coefficient of Z square, B is the coefficient of Z, C is the constant term. Evaluate B square minus 4AC, that is negative 8. Negative 8 is basically root 8 into root 1. This is in third form, 4 into 2, that's 2 root 2 into I. So this is B squared minus 4AC after the square root. And then look at the working. Minus 2, 2, 2, 2 is taken common out. The 2 divides. Minus 6 plus root 2, minus 6 minus root 2. They are conjugates of one another. Okay. Something, this is the same kind of thing, nothing special, except the constant thing was there. So it says it is given that the complex number is the root of this equation where k is a real constant. This time it's a cubic equation. Write down another root. So the other root has to be minus 1 minus root 3i. Now what I have done is that, first of all, again, I have taken the x square common out from these two. So the previous question was written in terms of z. This time it's written in terms of x. So I have taken x square common out. I have taken this thing, I've squared it. This is what I'm getting. And this is x square over here. This is x as it is over here. Now look at the working. Yes, the working was a little bit messy. So yes, this question was difficult. K into x plus 5 and then open it up. The working is shown on the sidelines. So that was not easy. It seems easy. It is not easy. You just need to have a very calm mind when you are trying out these questions. This cannot be done in a hurry. So a lot of people, they get distracted and they think that complex number can be done in a, like just a snap. It cannot be. It takes time. So if you come across a difficult question of complex number with lots of algebra, skip it, come back to it at the very end. That's a very practical, pragmatic thing that I'm explaining it to you. So let me just focus this thing. So now we are still on the complex number, the algebra part. Keep that in mind. So let me draw 3 boxes over here for complex numbers. This always gives me trouble when I'm trying to draw a box. Okay, that is the first one, not bad. That is the second one. Okay, that's the third one. Okay, so now when we are talking about complex number and we are talking about algebra, this is part 1, algebra. So there is, in algebra, there is too much algebra. So there is too much simplification required. And what else? Knowledge of quadratics, cubic, polynomial, remainder factor theorem. All these things are very necessary. Disguise quadratic and simultaneous equations. From P1, one is linear, one is non-linear, disguise quadratic equation. This thing is there a lot. So now let's talk about this thing. Let me go back over here, complex. And then what we do is that x, this is one root, this is the other root. Again, you form a quadratic equation, then you do the long division, you get the real root. So since a cubic equation has 3 roots, there are 2 complex conjugate roots and 1 root which is real. Now this is loci. Okay, this is that square root thing. We talked about one of the questions of square root. This was the other one. Nothing special. Yeah. Now focus over here. The coefficient of z square is I. The coefficient of z is a constant, 2, normal real number. The constant term is negative 3i. So in a quadratic equation, if the coefficients are here, the answers, the roots, they are conjugates. Sign of imaginary changes. But over here, look at this. A is I, B is 2, C is minus 3i. The b square minus 4ac is negative. Minus 2 plus minus square root of negative 8 divided by 2i. Now over here, first I wrote it like this. There is an I at the bottom. So I multiply and divide by I. So you don't need to write 0 plus I and 0 minus I. It won't make a difference at all. I plus minus I. So I into I is I square. I square is negative 1. You get the final answer. Now have a good look. When the coefficients have i's, you're not going to get the normal conjugates. These are different kind of conjugates. The sign of the real part changes. So this is root 2 plus I minus root 2 plus I. So the imaginary part, the sign does not change, but the sign of the real part changes. Yes, this thing occurs. This thing comes in the exam. So now this thing was about this thing. Let me go to the other part. That is the trig form, the polar form, modulus argument form, exponential form. So z is x plus iy. Real part of z is x. Imaginary part of z is y. And when we talk about the real number and the real number x and y axis, that's called the Cartesian plane. So yes, it is called the normal graph paper, the normal grid. That's called the Cartesian plane. This is after a French mathematician, René Descartes. Okay, Descartes. And this is also after some French mathematician, Argand. I don't remember the full name. Argand is part of his name. So for complex number, this is real and imaginary. Real would be normal number over here, I, and so on. And I just plotted a complex number over here. So now, since it's on the coordinate plane, what we can do is that we can find the magnitude, we can find the basic angle, we can find the angle with the x-axis. So if in the first quadrant, theta is equals to basic angle. Basic angle is always calculated with a positive ratio. It's change in y over change in x. And then that is how we write it. So we write root 2 cos of pi by 4 plus I sine pi by 4. So I think let me just write it over here. So z is, I think it is explained a little bit later because this was again during teaching. And hold for a second. Yes, it's explained over here, and then I'll come back to that. Cartesian form, modulus argument form. This r, that is the magnitude, that is the length of this vector. That is based upon Pythagoras theorem. This theta is calculated from here, but with respect to quadrants. So this was the basic knowledge. That's how you get it. Right now, all you need to do is this thing. Just get the magnitude, just get the basic angle, take care of the principal argument. Theta is with respect to minus pi and positive pi. Magnitude has nothing to do with I. So now over here, let's go back. And let's look at this. So the coefficient is 1, the coefficient is 1, magnitude is root 2. It's in the third quadrant. Basic angle is pi by 4, but in the third quadrant, we go clockwise. In the fourth quadrant, we also go clockwise. In the first quadrant, we go anti-clockwise. In the second quadrant, we go anti-clockwise because theta lies between 0 and pi, and theta lies between 0 and negative pi. So first and second quadrant is anti-clockwise, third and fourth quadrant is clockwise. We should also know that the geometrical relationship between a complex number and its conjugate, the sign of the imaginary changes. So if this is in the first quadrant, this is in the negative, a fourth quadrant. If this angle is theta, this angle is negative theta. So if theta is pi by 4, theta is negative pi by 4. Reflection of each other in x-axis. Same thing goes for second and third quadrant. So now that's the relationship, which is this. In the first quadrant, theta is alpha. In the second quadrant, theta is pi minus alpha. Reflection of this, so put a negative sign outside. Reflection of this, put a negative sign on the outside. So minus sign outside actually makes it alpha minus pi. That is what I've written over here. And then different kinds of questions can come. How do you convert from modulus argument form to Cartesian form? Just plug in the values, open up the bracket, and get the Cartesian form. If it's on the x-axis, the principal argument is 0. If it's on the positive y-axis, principal argument is pi by 2. This is positive x-axis, this is positive y-axis. If it's on the negative x-axis, there are two options possible. But since pi is inclusive, so we choose this one, we reject this one because only one answer is possible. If it's on the negative y-axis, then negative pi by 2. Now over here, what kind of questions are there? The complex number -1 plus 3i and 2 minus I are denoted by u and v respectively. In an Argand diagram with origin O, the points A, B, C represent the complex number u, v, and u plus v. So now you have u, you have v, u plus v. You're getting this. I have done the working over here. Sketch this diagram and state fully the geometrical relationship between OB and AC. So now this is basic vectors. So OB is there. What is AC? That's OC minus OA. That is 2 minus 1. This is 2 minus 1. So they are exactly the same vector. You can say parallel vector, same magnitude. So now I have plotted this thing. This is A. This is B. This is C over here, something like this. If they're asking for a triangle and some angle, so how will we work it out? They are asking the complex number U over V. So what is U over V? That is separate. So that is, you just find this thing. So now why did they ask in the middle? So this thing has nothing to do with the rest. We are talking about A, B, and C, A, B, and C. So C was already calculated. Prove that the angle AOB is this much. So AOB is related with these two. So now there are different ways of doing it. The first method is I have used vectors, scalar product. I find this one to be the easiest. So now take two vectors diverging from a point. This is O, this is A, this is B. So one vector is OA, the other vector is OB. This is OA, this is OB. Of course, it's a 2D vector. There is no 3D over here. Magnitude, cos theta. Look at the working in the exact form. So theta comes out to be 3 pi by 4. Cos inverse of a negative value is obtuse. So the basic thing about vectors, which we will see soon. The second thing, I have OA, I have OB, I have AB. I find the magnitude of each one of them. This is like cosine rule that I'm using. So I need this particular angle. So AB magnitude, that is the greatest. I'll use cosine rule with perspective of this. So root 25 whole square is root 10 whole square, root 5 whole square minus 2 into root 10 into root 5 cos theta. This is the numerator. This is the denominator. Look at the working. Everything is done in the exact form. So exact form, that is the first priority that we do. Okay, Jay. So this thing is done. Third one, based on principal argument. So now think about it. This thing over here, that is based upon this angle. This is based upon this angle. So the total angles should be a sum of these two. So now I have written the answer in the exact form because otherwise it would be in decimals. So if maybe the examiner might be asking something like this, so you can work it out this way. So this is the second quadrant. So theta is this thing. And this is the first quadrant. This is the basic angle and so on. I've used the basic angle. And this is this thing. Theta of A should be, this is pi minus this. So this is pi minus this thing plus this thing. Something like this. The complex number U is defined by the way, these are all past paper questions that I'm doing. The complex number U is defined by such and such. Find U in the form x plus iy, where x and y are real and exact. Find the exact modulus and argument of U. So 1 minus root 3i, 1 plus root 3i, 1 plus root 3i. This is normal multiplication. This is 1 square plus root 3 square. Simplified, this is what you're getting. Root 3 is positive, I is positive. It's in the first quadrant. Theta is equals to basic angle. Magnitude of U is Pythagoras theorem. Basic angle is pi by 6. Theta is pi by 6. That is how we write in the modulus argument form. Now, some rules related to multiplication, division, subtraction. So now if Z1 is R1 cos of theta 1, cos theta 1 plus I sine theta 1, Z2 is R2 cos theta 2, I sine theta 2. So when we talk about multiplication, very important rule. Again, look at the videos of 2025, the complex numbers, the 4 videos. And there are some very, very good questions related with transformation. It is about rotation. It is about enlargement. So now magnitude of Z1 is R1, magnitude of Z2 is R2, argument is theta 1, argument is theta 2, respectively. If we want the magnitude of the complex number after multiplication, it's the individual magnitudes multiplying together. Similarly, if one complex number is divided by the other, what is the overall modulus? One modulus divided by the other. Argument of Z1, Z2, that's argument of Z1 plus argument of Z2. Argument of Z1 over Z2, argument of Z1 minus argument of Z2. So now rules of logs, the argument rules are like log, the power rule. Z n modulus, that's the same thing as Z modulus raised to power of n, argument of Z raised to power of n times argument of Z. Some examples, why don't you have a good look at it? Okay, so just have a good look. Acha ji. So now this is done. Uh, magnitude of Z is 2, magnitude of W is 3, magnitude of ZW, that is 6, magnitude of Z over W, that's 2 over 3. Argument is pi by 6, argument is pi by 4. Product, arguments add up. Division, arguments get subtracted. Pi is inclusive, negative pi is exclusive. ZW can be written in this form, ZW can be written in this form. If you expand it, you get the Cartesian form. The power rule, modulus of Z is 2, argument of Z is pi by 6, Z square modulus is Z modulus squared. Argument of Z squared, 2 times argument of Z. 1 over Z modulus, that is Z raised to power of negative 1. That is modulus of Z raised to power of negative 1, which is half. It's not negative, it's indices. Argument of Z raised to power of negative 1, that is negative 1 into argument of Z, negative pi by 6. Z square is written this way, Z 1 over Z is written this way. What if sometimes the arguments add up and the range is exceeded? Because this is 13 pi by 12. So that is pi plus pi by 12. So the basic angle is pi by 12 over here. So this thing would be pi minus pi by 12 with a negative sign. That is what I've written. So make sure it stays within the range. So that range has to be there. And that range is what? That range is theta lies between pi inclusive, negative pi exclusive. Cartesian form, modulus argument form. So that is the Cartesian form. That is x, that is y, that is the Cartesian form. The modulus argument form, and then we have the exponential form. So this is related with this thing. Just pick the r, just pick the theta. Just pick the r, just pick the theta, and write it like this. This is r, this is theta. So this is 3ei pi by 4. This is r, this is theta, this is 5ei pi by 4 with a negative sign because of that thing. So this is r, this is r, this is r, this is r over here. Okay. And this is pi by 4, this is theta, this is negative pi by 6, this is theta, this is pi by 4, this is negative pi by 4. So I think there is this small error. This is pi by 6, my bad. Okay. So this is pi by 6 and with the negatives. All done. Now something like this. Let me just show you a question, which is a good one. Yes, this one, this is necessary. Find the modulus and argument of u. So u is 1 minus root 3i. This is in the fourth quadrant. Magnitude is 2. Basic angle is pi by 3. It's in the fourth quadrant. Theta is minus pi by 3. Show that mu cube plus 8 is equals to 0. In other words, show that mu cube is negative 8. So use the knowledge that you have just applied. So mu cube, u cube, not mu. I just got into m1. So this is not m1, this is u. U cube modulus is the same thing as u modulus cube, which comes out to be 8. Argument of u cube is 3 times argument of u, 3 times negative pi by 3, negative pi. When I write it over here in the modulus argument form, sine of negative 180 based upon the curve, this is 0. Sine a cos of negative 80. So this is cos is like this and like this. So cos of negative 80 is minus 1. Negative 80, 180 means negative pi. So therefore, we are left with u cube is equals to negative 8. Something like conjugates thing. Yeah, this is also a nice simultaneous question. Find the complex number z satisfying the equation z star plus 1 is 2iz. So z is x plus iy, z star is x minus iy, iz, that's I into x plus iy, that is minus y plus ix. So now what happens if a complex number is multiplied by z? What kind of rotation is this? What happens if a complex number is multiplied by negative iz? What kind of rotation is this? Again, I would advise you to look at that complex number videos. So I have written z over here. I have written z star over here. So let me highlight this thing. This one is z, x plus iy. This one is z, that is x plus iy. And then we have the z star thing. So z star thing, that is this thing, minus y, minus y plus ix. This is I into z. So hold for a second. This is, let me just label it properly. This is iz with this thing. And this is multiplying with 2. That is good enough. That is iz over here. And this purple one, z star, that is this thing. Got the idea? So we are not using z in the original equation. We are using iz. And then the real part equals the real part. The imaginary part equals the imaginary part. Real equals real. That is equation number 1. Imaginary equals imaginary. That is equation number 2. You solve it simultaneously. You get the final answer. Okay. Now something like, yeah. It says, throughout this question, use of a calculator is not permitted. The complex number root 3 plus I is denoted by u. Express u in this form, giving exact values of r and theta, hence or otherwise state the exact values of the modulus and argument of u raised to power of 4. So now u is root 3 plus I, first quadrant, basic angle is pi by 6, theta is pi by 6, magnitude of u is r, which is 2. U raised to power of 4, that is 2 raised to power of 4, which is 16. Argument of u raised to power of 4, 4 times argument of u, that is 2/3 pi. So this is r, this is argument. So 16 ei 2/3 pi. Yes, a very nice question. It says the complex number u is defined by z over u is given as this. That simplifies to this 3 plus 4i. Show on a sketch of an Argand diagram the points A, B, and C. So the A is U, which is 3 plus 4i. B is 7 plus I. C is 1 minus I. By considering the argument of 7 plus I and 1 minus I. Now keep in mind there is 7 plus I and 1 minus I. Okay. So now, let me just highlight it. 7 plus I is this thing, the numerator. And 1 minus I is this thing, and this is based upon this thing. Don't worry about this. So 7 plus I, that is this thing. And U is the division of these two. So U is the division of these two over here. So there is U, there is B, there is C. Now have a good look. U is red is blue over green, red, blue, green, red, blue, green, red, blue, green. So now this combination, I'll just have a look. So now A is 3 plus 4I. A is 3 plus 4I. B is 7 plus I. B is 7 plus I. C is 1 minus I. C is 1 minus I. So now when we divide one complex number by the other, you get 3 plus 4I. Okay. So now what has this to do with all this thing? So now what we can do is that U is 3 plus 4I. Focus on U. Alpha is tan inverse of 4 over 3. So alpha is tan inverse of 4 over 3. This is 4, this is 3. The basic angle, it's in the first quadrant. Theta is alpha, tan inverse 4 over 3. Now, focus. I have written U twice. Okay. Focus on Z only. So now I'm calling it Z. So Z is 7 plus I. Now, where is Z? 7 plus I, that's also in the first quadrant. The height is 1. The base is 7. So alpha is tan inverse of 1 over 7. First quadrant, theta is alpha. Focus on W, which is denoted by the alphabet C. This is 1 and minus 1. So now we can calculate the numbers. The basic angle is pi by 4. It's in the fourth quadrant. Theta is minus of alpha, minus of tan inverse 1 over 1, minus of pi by 4. So no need to write this thing in terms of tangent because this is so easy to evaluate. Got the idea? Now the relationship is this thing. Argument of U is argument Z over W. The division rule. So now over here, we have this thing, argument of U. So now this is argument of U is this thing. And argument of Z, that is this thing. And argument of W, that is this thing. So now there is, because of this, there is a negative sign over here. So tan inverse 1 over 7 minus pi by 4, that is pi by 4. That is how this thing is obtained. A very classical question. There are also questions related with conjugates. So now let's move on and let's go to the concept of loci. So now almost 1 hour has passed and we are still on complex number. So complex number will be taking a lot of time. So I think we'll be taking another 20-25 minutes on loci. Then I'll give the first break. After the break, vectors and numerical solution. Or maybe let me just do a little bit of binomial also. So now over here, loci, there are 3 kinds of loci. First of all, the word loci is the plural of the word locus. A locus, set of points fulfilling a certain criterion. First, it was an O-level maths, but more than a year has passed. They have removed it from the syllabus, which is not a good thing to do. Z minus A plus BI modulus is equals to R. If we get a complex number of this form, so now this complex number, if we get a complex number, variable complex number Z, and then this is how it's written, modulus on the left-hand side, constant on the right-hand side, then minus sign, that is a must. So now this minus sign is there. And whatever is on the inside, this A comma B, the real and the imaginary, they are the center of the circle. And this R is the radius. So they can ask about drawing, shading, greatest these values with respect to loci. If it's only Z modulus, that means the center was 0, 0. This number over here, that's the radius. Of course, the P1 circle equation, that is also needed. Like I've used it over here. If they ask me the Cartesian equation, I'll use x minus h whole square, y minus k whole square is r square. This is 0, this is 0, this is radius square. They can ask about inequality, solve the inequality, Z modulus is less than or equal to 2. So less than or equal, greater than or equal, solid line, solid circumference. lesser, greater, dotted line, dotted circumference. Lesser, lesser than or equal, it means inside the circle, and if it's equal, including the circumference. If this is greater than or equal outside, including circumference, only greater, excluding the circumference. So now over here, this is the shaded region. Mark any important points like 4, -4, and so on. Worked example 2, minus sign adjustment has to be there. And the diagram has to be realistic. Now this is 1 and -2, and the radius is 1. So that means it should be touching this circumference, the axis, the y-axis, the equation of the circle. If modulus of z lies between two values, that means there are two concentric circles having the same center, which is 0, 0. One has a radius of 1, the other one has a radius of 2. It's outside of the small circle, inside the biggest circle, and that is the donut that you get. Again, in 2025, there was this one circle and like this, and I think this was the shaded region. Again, check it out. So first time I've seen two circles together, but not with the same center. The case number 2 is z minus a plus bi modulus, z minus c plus di modulus. If there is modulus on both sides, what you get, what the loci is, the loci is the perpendicular bisector of the line joining the points A, B and C, D. So there is A and B, and then there is C and D. Minus again is a must. And you have to find the perpendicular bisector, and that can be done using coordinate geometry. For example, in this particular question, I have 1, 2, I have 2, 1. Find the midpoint. Find the gradient of AB, and maybe this is A, this is B. So like this, the gradient is negative. So do the negative reciprocal thing, and you get the gradient of the perpendicular bisector. Equation of perpendicular bisector, y minus y1 is equals to mx minus x1. You get y is equals to x. Draw a realistic diagram. Now, if this same question is asked about inequality, so now the question is about inequality. So we would say z minus 1 plus 2i, z minus 2 plus I. Method 1, this is using algebra. Let z is equals to x plus iy. Real part of z is x, imaginary part of z is y. Real, real, group them together. Real, real, group them together. Imaginary, imaginary, group them together. Imaginary, imaginary, group them together. So now the first thing is on the inside of the modulus sign. Now what is happening? We know that modulus of a complex number is the real square plus the imaginary square under root, nothing to do with I square. So now look at the working over here. This is all algebra. So we have x minus 1 whole square, y minus 2 whole square, x minus 2 whole square, y minus 1 whole square. When we square both sides, the square root disappears. And look at all the cancellation. What are we getting? The inequality always has to be written from the perspective of y, and y should be on the left-hand side. So y is greater than or equal to x. We shade the required region in this one. Keep that in mind. So over here, greater than or equal to means above the line. Lesser than or equal means below the line. Solid dotted, take care of that. So that is how you're getting it. Now the next method is based upon the concept of loci. That is this thing. That let's call this point as A. Let's call this point as B. And focus on the lesser sign. We will always focus on the lesser sign. Maybe if the question was like this, I'll switch the places and then focus on the lesser sign. It means this point A is closer to the loci as compared to B. A is closer to the line, the perpendicular line compared to B. So now this is the point, this is the point. The equation of a line, that of course will be found using coordinate geometry, but this one is the required region, so that is why we mark above the line. Case number 3, it has to be about argument. It has to be about a half line. This is the angle that it makes with the horizontal. It's a half line, not a full line. If it's a full line, there would be two possible theta. So we just want one theta. Therefore, it's starting from A comma B and making an angle of theta with horizontal. Argument of Z is pi by 4. So the center is 0, 0. That's a 0, 0. This is pi by 4. And if I want a Cartesian equation, I can use this knowledge from P1. Tangent of theta is gradient. M is tangent of pi by 4, which is 1. Y-intercept is 0. Y is equals to x plus 0. Similarly, over here, argument Z minus 1 plus I. So now 1 and I, that is the starting point. The angle is 2 pi by 3. Draw a dotted line as a launch pad and just mark the angle 2 pi by 3. Now you can see the gradient is negative. So tangent of 2 pi by 3, of course, will also come out to be negative. The point through which it's passing is 1, 1. So if they ask for the equation, you have to solve something coordinate for some coordinate simultaneously like that. So this is the equation that you will use. Something like this. Argument of Z minus 1 plus 2I minus adjustment is a must. So now the center is 1 and negative 2. The angle is negative pi by 4 going like this. Again, the gradient is negative. These are the coordinates. Y minus y1 is equals to m, x minus x1. Final answer in the form y is equals to mx plus c. Argument of Z lies between two values. These are two half lines. One is making an angle of pi by 6. The other one is making an angle of pi by 3. So it's an open region between the two lines, two half lines. This is the summary of all of this. Let's move on. Shade the region satisfied by both the inequalities. So Z modulus is lesser than or equal to 2. An argument of Z lies between the two angles. So what is the final region? Have a good look. The final region is in between the two lines and inside the circle. That is the final region. Something like this. The modulus example, modulus on both sides example from the previous worked example, that is y greater than or equal to x, and a circle having a center 0, 0, radius 3. So draw the circle. It should be all the points inside the circle, but above the full line, above the perpendicular bisector. That's how you shade it. Now, I have categorized the questions like these, and there would be some greatest least values questions also coming up. So the red one, that is about the circle. The blue one, that is perpendicular bisector. Green one is half line. The purplish one is real and imaginary part. And the some mauve color with the white thing in it, greatest least values. Now, something like this. I'm just focusing on the loci question. On a sketch of an Argand diagram, shade the region whose points represent complex numbers satisfying the inequalities. So now we have this thing. The adjustment is necessary. Let me highlight it. So this adjustment is done. It's a circle. This is the center. This is the radius. Since it's lesser than or equal, it's a solid circumference and it's inside. Argument of Z minus 0 plus 0i. Two half lines. This is the starting point. One making an angle of pi by 4. Negative, that means go clockwise. This one is positive pi by 4. That means go anti-clockwise. And it's just about shading, no greatest least value question as such, only shading, no equation is asked. That is the circle realistic diagram, two half lines, and inside the circle and between the two half lines. Something like this. This one is, there are two inequalities. Let me shade it. The first one is this, Z minus U modulus is less than 1. U is already given over here. The other one is Z modulus is less than Z plus I modulus. That is a perpendicular bisector, which is very easy to evaluate because this is 0, 0, this is 0 minus 1. So this is 0, 0, this is 0 minus 1, and this is the perpendicular bisector, y is equals to negative half. So I've taken this thing to be 1 unit for just to get the diagram to be a bit bigger. Inside the circle, dot it. And it's closer to A. So A is above this line. Got the idea? So that is the dotted line. A is above, B is below. So inside the circle and shade the region closer to A. So that's how it's shaded. Dotted line, dotted circumference. something like this, something to do with the real thing. Find the modulus and argument of u. That thing was done, and we are focusing on this one. That is this thing on a sketch of an Argand diagram. Shade the region whose points represent complex number z, satisfying both the inequalities. So that is always the wording that they will use. You don't have to focus on the wording as such, as long as it's only about shading. Just focus on this thing. Just focus on this thing. So now this one, z minus u modulus is less than or equal to 2. That is a circle, center, radius, inside, solid. This one is real part of z is greater than or equal to 2. So real part of z is x. That means x is greater than or equal to 2. This is a vertical line. So now this is greater than 2. That means it should be on the right-hand side. And it's inside the circle, very realistic diagram. So the small segment over here, that is the shaded region. Let's focus on greatest least values. Some basic things that needs to be taken care of. That is sine, cos, tan, Pythagoras theorem. Of course, sine rule, cosine rule. Radius is perpendicular to tangent at the point of contact. Tangents drawn from an external point to a circle are equal in length. That means TA is equals to TB. This is the radius. This is the radius. This is the center. This is the common line. These are two congruent triangles. This angle equals to this angle. This angle equals to this. This is 90. This is 90. Shortest distance from point to a line, it's always the perpendicular distance. So if there is a line and they're asking me the shortest distance from this point to this line, so from this to this, let me find the horizontal distance, which is 5 units. This angle, if I have this angle, I can use this angle to find this thing. So this is the hypotenuse. This is the opposite. So M is 1, C is 2, y is equals to x plus 2. Tangent theta equals to gradient of the line. Theta is pi by 4 or 45 degrees. So now this is the triangle that you need to focus on. Sine of 45 is d over 5. Hence, you find the value of d. Some questions based upon complex number. If argument of z plus 3 modulus is pi by 3, find the least value of, let's say, argument of z minus 3 plus 0i. So I just have, my bad. This is the complex number equation of this thing, half line, starting from minus 3, 0. That is this thing adjusted, making an angle of pi by 3. So now the angle is already given. And I want the shortest distance from 2, 0. So this is 5 units. This is pi by 3. Sine of pi by 3 is d over 5. D is this much. Greatest least value distance, distance from point to a circle. This is the outside point. This is a point on the center of the circle. If I find this distance, if I subtract the radius, I get the shortest distance from outside point to the circle. If I calculate this distance and add the radius to it, I'll get the greatest distance. What kind of a complex number question is being asked? If modulus of z minus 3 minus 3i is equals to 2, that is a circle, that is the center, that is the radius. Find the greatest and least values of modulus z plus 1 modulus z minus 3 plus 4i modulus. So modulus of something means distance from that point to the circle. Also over here, modulus of this thing, that means from this point to this loci, find the distance. In the case of line, they would only be asked for the shortest distance because there are infinite possibilities for the longest distance. Because the line is infinite, it keeps on going. Keep that in mind. But from the point to a circle, now they are asking magnitude of this thing. That means from this point, from 3, 4 to the circle. So take 3, 4. Take 3 minus 3. Find the distance, that is 7 units. Subtract the radius. Add the radius, subtract the radius, you'll get the least value. Add the radius, you will get the greatest value. A question in which maximum minimum value of argument is being asked. Just look at the question. It says the complex number u is given by such and such. That becomes 1 plus 2i. Sketch an Argand diagram showing the point representing the complex number u, that is just a dot. Show on the same diagram the locus of the complex number z such that z minus u modulus is equals to 2. Find the greatest value of argument z for points on this locus. So now that is the circle that's drawn. And now what are they asking us? They are asking us the greatest value of argument of z for point on this locus. Now, first of all, if I talk about this thing, so argument of z has to be a half line, correct? So it has to be a half line over here, starting from the origin, and it is with respect to this circle. So if they would have asked you for the least value, that was very obvious, that was 0. For the greatest value, you go like this. Now focus on this. Using this coordinate, using y, using x, I can find this angle theta. Very simple. This is the radius. So this radius is touching the tangent. So I have the value of radius. I have the value of this thing. I think it's root 5. So again, I can find this angle, which is beta. So the maximum value of argument of z is theta plus beta. But if you look very closely, this is like tangent drawn from an external point to a circle. So these two angles will come out to be the same, as you will soon see. First of all, the small triangle, that is, this is 2, this is 1 hypotenuse, that gives me root 5. Tangent of theta is 2 over 1, 63.43 degrees. You can work in degrees, you can work in radians unless otherwise specified. Over here, this one is root 5. This one is the radius, which is 2. You find beta, but this time using sine. That also comes out to be the same. Already told you it will come out to be the same. No, it's not a coincidence. So nope, because it is a circle property. It's a circle property. Tangents drawn from an external point are equal in length. So that is congruent triangles. Argument of z is 63.43, 63.43. That's a final answer. Now, one last question like this. Sketch a diagram showing R consisting of the points representing the complex number z. So draw this thing. That is a circle. Center is 4, 4, radius is 2. Center is 4, 4, radius is 2. For the complex number represented by points in this region, it is given that modulus of z lies between P and Q. In simple words, modulus of z means distance. Distance from which point? From 0, 0. So this is smallest value. This is the greatest value. You need this. From this outside point, which is 0, 0, to this circle, the least and the greatest value. Argument of z lies between alpha and beta. So it means draw a half line, find the least value, find the greatest value, just like the tangent that you have drawn. Find the values of P, Q, alpha, beta, giving your answer correct to 3 significant figures. So now, first of all, this is the center, 4, 4. This is the outside point, 0, 0. Let me find the distance, that is root 32. I have left the answer in the exact form. Of course, you can convert it into decimals. So now from here to here, that is root of 32. Subtract the radius 2, you get this distance, that's the least value. From here to here, find the distance, add the radius, you get this value, which is OB. So least value, according to the labeling that I have done, so least value is OA. So this is OA magnitude. And the greatest value is OB. They have labeled least to be P, greatest to be Q. Next one, the same diagram. Now let's focus on the triangles. So now we have this and this. We have this distance, that is root 32. We have this distance, that is 2, the radius of the circle. Can I find this theta? Yes, I can. And now we know that it's a congruent triangle. So if this is theta, this is theta. So once I find the value of theta, the least value of argument of z should be this angle, which is 45 degrees, because this is 4, 4. This is 0, 0. So this is technically the line y is equals to x. It is making an angle of 45 degrees. So 45 degrees minus theta, that's the least value. And up till here is 45 degrees plus theta. That is the greatest value. Have a good look over here. So now a sine of theta is 2 over root 2. So sine of theta is 2 over root 32. That comes out to be 20.7 degrees. And over here, using 4, 4, this angle is 45 degrees. For the least, 45 minus this angle. For the greatest, 45 plus this angle. So I think that's enough of complex numbers. And let me just quickly go to partial fraction that was studied yesterday, but something to do with binomial. I just want to have a good look at that. So this is partial and binomial. Is binomial in this one? No, this is just partial. Let me just double check. This is partial. And let me look at binomial. I think it's there. It should be there. So this is differentiation, binomial. I think must be in this one, modulus. Nope, it's not here. I think it must be in some other PDF, any which way. Let me just partial and binomial. How come the binomial is not there? Okay, there it is. So now let me show you one question over here, which is about binomial and partial fractions. It says this is the numerator, highest power is 2, denominator, highest power after multiplication is 2. It's an improper fraction. That is what you have to check first. Step 1, improper. How can we make it proper? Write it as quotient, remainder, divisor, one step of long division. Multiply the two linear factors, we get this thing. This is the inside thing. This is the outside thing. Take the highest power 12x squared, take the highest power 3x squared, you divide, you get 4. Multiply it out, change the sign and add. That is the rule. Quotient is 4, remainder is 8x plus 7. Divisor, I have factorized it. So you will write this thing like this. Now decide on the case. It's partial fraction, case number 1, denominator with linear factors. So take this thing, break it up into partial fraction, don't forget the 4. So this is a over x minus 1, b over 3x plus 2. Take the LCM, this thing equals to this thing. Let x is equals to 1, a comes out to be 3. Let x is equals to 0. So I could have chosen 3x plus 2 equals to 0, x is minus 2/3, but I'm not choosing that. What I'm doing is that let me plug in the value of this thing over here, which is a. So a is 3. And now let me choose any simple value, which is 0, and I find the value of b. And the value of b is found. So now this is the answer for the partial fraction. Okay. Now every step has been shown. Now if it says, let's expand it binomially. So now what we will do is that this 3 over x minus 1, that is written as 3x minus 1 raised to power of negative 1. Now make sure that you write the constant first and then the variable. Now make sure that the first term is 1. So I've taken minus 1 common. But this whole thing is under the power of negative 1. So negative 1 raised to power of negative 1, 1 minus x raised to power of negative 1. This is simplified, and that is what you're getting. 1 minus x raised to power of negative 1, the binomial formula, that is 1 nb power 1 over 1 factorial n minus 1, b raised to power of 2 over 2 factorial. That is what I've applied. Take care of the positive negative sign, take care of this division thing. You get these three terms, multiply with negative 3, you get this thing over here. Now let's focus on this thing, 1 over 3x plus 2, and I'm using this negative 1 over here. First term is a constant, but it's not 1. So take 2 common out. This is 1 plus 3 over 2x, the whole thing raised to power of negative 1. 2 raised to power of negative 1 is half. Let it remain over here. Let me take this half, multiply with negative 1, that is negative half. Write down the first 3 terms over here. Simplify. A division by 2 factorial is multiplication by 1 over 2 factorial. If you feel comfortable, write it this way. Simplify, lots of care needs to be taken over here. And you get these three tips. 4 was there before. This was the first expansion. This was the second expansion. The minus sign was already taken. That's why it's a positive sign. So constant, 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 add them up. X term, add them up. X square, add them up. And that is what you're getting. Okay. So now this thing is done. And let's take a small break over here. This modulus, let me remove it. And we got started with 11:04 and we studied till 12:24 p.m. So now it's time to take a break, and there will only be one break. So complex is done, and binomial plus partial, that one question needs to be explained, that is done. So now when we will come back, let's say after 20 minutes, and then it would be 12:45 p.m. onwards. Let's get started with vectors. Let's get started with the numerical solution. So these two things needs to be there. Numerical solution, another name for that is iteration. That is part and process of that. So let's wait for that. Take care, everyone. And we will meet soon, inshallah. Acha ji, Assalamualaikum everyone. I am back and let me open my uh, tube also. Okay, just double check one thing. So now, okay, let me change the voice. Okay. So now people, let's start with vectors. This is 1246. And let's start with vectors first, and then we will go to numerical solution. So now when we talk about vectors, so first of all, we need to understand that vectors is linked with coordinate geometry. The column vectors, magnitude, maybe sometimes the angle, Pythagoras theorem, everything. So we know this. Let me just start from here. A coordinate can be written as a position vector and vice versa. A two-dimensional coordinate can be written as xi plus yj. And if there is a third dimension, we add a k over there. Magnitude of a vector is x squared plus y squared under root. The distance formula between 2 points can also be used in a manner of vectors. We can find a vector between 2 points and find its magnitude. Parallel lines, they have the same slope. Collinear points. Parallel vectors, if points lying on the same straight line, the vectors are parallel. AB is parallel to BC, it's parallel to AC. AB is 2, 4. BC is 3, 6. Take 2 common out, 1, 2. Take 3 common out, 1, 2. Since AB and BC are parallel, one vector divided by the other is a scalar multiple, it's a constant. And that's how you can also get the ratio of the length of the two vectors. This is AB, that is the distance, BC, that is the distance, AB is to BC, that is 2/3, that is the same thing as the scalar multiple. This is ratio of magnitude of two vectors. 3D vectors, there is x, y, and z. OQ is written as xi, yj plus zk. Magnitude of this vector, that is x square, y square, z square under root. Distance formula, x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. You can find the vector AB and then find its magnitude. Just the basic thing. The same thing over here, 2, 3, 4, 4, 6, 8. 4, 6, 8 can be simplified as 2 times 2, 3, 4. OA, OB. So technically, OB is 2 times this one is OA. If OB is a scalar multiple of OA, that means OB and OA are parallel. Scalar product. Angle between two vectors is found by scalar product. So we would say U dot V, that is U modulus V modulus cos theta. We multiply the I with the I, the J with the J, the K with the K. This is 0, 1, 3. This is 2, negative 1, 4. That is the magnitude. That is the magnitude. And then I with I, J with J, K with K, magnitude of U, magnitude of V, and we get this answer. The examiner accepts it in degrees as well as radians, unless otherwise stated. If this left-hand side of the equation, the numerator of this thing, if it's positive, angle is acute. If the numerator is negative, angle is obtuse. If the numerator is 0, angle is 90 degrees. That means the left-hand side of the equation, if it's positive, acute, negative, obtuse, 0, 90 degrees. We get a rule for perpendicularity also, very important. If A is perpendicular to B, A dot B is 0. Or if A dot B is 0, A is perpendicular to B. If they talk about coordinates and they ask for angle between two vectors, it is a must to follow this process. Take two vectors both diverging from the angle point, or take two vectors both converging to the angle point. For example, they're asking for the angle B, A, B, C. So if I'm taking two vectors which are diverging, that would be BA and BC. If I'm taking two vectors which are converging at B, that would be AB and CB. So let me just, the arrows, they were missed earlier. So now this is BA, this is BC. You can draw a diagram and say the same thing. This is AB, this is CA. My tendency is to take diverging vectors. For example, this is OA, this is OB, this is OC. Find angle ABC. BA, that is OB minus OA minus OB. That is BA. BC, that is OC minus OB. This is BA magnitude, this is BC magnitude. Just apply as you would apply it before. Now, sometimes, not sometimes, actually more than sometimes, the examiner will ask you for theta, cos of theta in the exact form. And then the next part would be about some area thing. So for area thing, we need sine also. So cos of theta is 1 over root 70. Opposite is found using Pythagoras theorem. Sine of theta is root 69 over root 70. So if I want to use half AB sine C, now I have sine of theta. 3D diagram, it could be about cube, cuboid, prism, cylinder, cuboid, and I've written cuboid twice. So I, J, K are taken along OA, OC, OD respectively. OA, OC, OD respectively. Let's say it has a length of 6 units. This is 4 units. This is 5 units. So anything in this direction would be anything in this direction would be I. Anything in this direction would be J. Anything going up should be K. And opposite direction would be negative. And whatever angle that they're asking, just take a walk and evaluate it. Now, let's say in some question, if they have given us that cos theta is coming out to be negative half, it's an obtuse angle. But the examiner is insisting on the acute angle. So what needs to be done? That is, discard the negative sign. So just discard this negative sign and answer will come out to be acute. Or alternatively, cos theta is equals to negative half. Theta comes out to be 120 degrees. Now subtract it from 180 degrees. If someone wants to follow this process, so 180 minus 120 is 60 degrees. The same thing as this. Something like this. It says, with respect to the origin O, the vertices of a triangle ABC have position vectors such and such. Using scalar product, show that ABC is right angle. So we have OA, OB, OC. Angle ABC, take two vectors diverging from a point. Let me take BA, which is position vector of second letter, OA minus position vector of first letter, which is OB. Let me evaluate BC, which is OC minus OB. Magnitude of BA, magnitude of BC. Apply this thing as such, you don't need the magnitude because they were talking about right angle. So the dot product would be 0. So this is extra for this particular question. If they were asking about the angle, yes, this is needed. But since the left-hand side of the equation is becoming 0, that means the angle is 90 degrees. Even if you include it, cos of theta is 0, theta is 90. Now, what else is there? Show that triangle ABC is isosceles. So we calculate BA magnitude, we calculate BC magnitude. I need to calculate AC vector and then the magnitude, that is root 18. So now I have 3, I have root 18. So root 18 is this thing. Since it's a right angle triangle, I can say half into base into height. That's the area. Have they asked for the area? No, they are asking the exact length of the perpendicular from O to the line through B and C. That will come later on. That I'll just explain to you. Something like OA is given, OB is given, OD is given, ABCD is a parallelogram. So it has to be in a proper order. And A, B, C, and D. So this is OA, OC, OB, OD. OC is written as XYZ. If it's a parallelogram, midpoint of the diagonal is the same. So A and C is diagonal, B and D is diagonal. Red, 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 red. The sum of these two red should be equal to sum of these two red, because this two will divide any which way. Same thing goes for the blue, the blue, the blue, the blue. Same thing goes for green, 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 green. So that is how you find these answers. Method 2, the parallel vectors. We have A, B, C, D, just a diagram in which the labeling is done correctly in an anti-clockwise direction and there is no hip hopping in between. So now this is A, C, this is B, D. So if I say AB, let's evaluate AB. AB, OB minus OA. Let's evaluate DC, that is OC minus OD. Let me write OC as it is. If it's a parallelogram, this should equal to this. Hence, you find the value of OC. Now, someone can say, can we use this thing? AD is the same thing as BC? Of course, yes. And I think that is the other one. And now they are saying, find the area of parallelogram. Verify this parallelogram is not a rhombus. So I have AD, I have AD length, I have AB. AD length is root 9, 3. AB length is root 14. The adjacent sides are not of the same length. Therefore, even though it's a parallelogram, it's not a rhombus. Find the angle BAD. So BAD, take two vectors diverging from this point, AD, AB, and then find the area of this triangle. Half AB sine C, double it, you find the area of the parallelogram. So BAD, this is AB, this is AD, this is the magnitude. Magnitude, use scalar product, find the angle, that is 100.3 degrees. Area of triangle, half AB sine C, half AB sine C. Area of the other triangle should be 2 times this. So therefore, I forgot to write this 2 over here. Let me write a 2 over here because these two are congruent triangles. So this 2.5 cancels out, root 14, root 9 sine of this thing. That is the answer. Now starts the concept of the 3D equation kind of thing. Equation of a line in 3D. We have this thing. That is R is equals to A plus lambda B. R is the position vector of any point on the line. A is the position vector of a fixed point, something similar to y-intercept. B is the direction vector, something similar to gradient of a 2D line. Lambda is a parameter, a constant which can take different values, just like the parametric of differentiation. Parallel lines have the same direction vector, same means exactly the same or scalar multiple. Different terminologies of different symbols that we use for lambda. Lambda and mu, that's Latin, Greek. S and T, that's English. Find the equation of a line passing through this point and it's parallel to this vector. So parallel to something, that is the direction vector. Passing through this point serves as the fixed point. Now I'm plugging in values of lambda to generate points. If I plug in value of lambda is 0, I get this point. If I plug in value of lambda is 2, I get another point, and so on. Worked example 2. Find equation of a line passing through these 2 points. So I can take AB to be the direction vector, BA to be the direction vector. I can take A to be the fixed point. I can take B to be the fixed point. So this is AB. This is BA. First equation, have a good look. There are 4 possible equations over here. There are 2 options for the direction vector, 2 options for the fixed point. That is why there are 4 possible equations. That is there. Now the next one, point lies on a line. So now there are 2 points. I need to check which one lies on the line. So let me plug in this point over here. Let me plug in this point in place of R, in place of R. There are 3 equations in each case and only one unknown. There must be a reason for it. That reason is, if the value of lambda is the same in all 3 equations, That means point lies on a line. So this is Q, and value of lambda is the same in all three equations. This over here is R, and the value of lambda is different. Two are same, one is different, all three are different, it's different. The scenario in this case is over here, first one, if the value of lambda is the same in all three equations, point lies on a line. If not, point does not lie on a line. The same thing, plug in value of lambda to generate different points. So one point is obtained by only one value of lambda. That is the logic over here. Angle between two lines, we just studied the direction vectors. That is the decision makers. And we apply the concept of scalar product. So this is 1, 1, 1. This is 2, 0, 3. Apply these two. So this is 1, 1, 1. And that is the magnitude of 1, 1, 1. That is root 3. This one is 2, 0, 3. That is the magnitude, root 13. So now apply this concept, IIJJKK divided by this, that is cos theta, hence we find the value of theta. Cartesian equation of a line. Let me just tell you the basic. That is the direction vector, it will go down in the denominator. X minus something, Y minus something, Z minus something. So we will write the X coordinate, Y coordinate, Z coordinate. Direction vectors in the denominator, minus, 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 the X, Y, Z coordinate of the fixed point. Very simple. Parallel, intersecting, and skew lines. If two lines are parallel, the direction vectors are scalar multiple of one another. 1, negative 2, 3. Double it, 2, negative 4, and 6. Multiply the original by negative 1, negative 1, 2, and negative 3. Multiply the original by 10, 10, negative 20, 30. This is not. So the first four lines are parallel, the fifth one is not. Intersecting on the same plane, coplanar, non-parallel, lines will intersect. Skew, different planes, not intersecting, lines are not parallel, lines are not intersecting, such as skew lines. For example, you are on the road and on the top there is a bridge. You are on the road and below there is an underpass going. So these are examples of skew lines. They usually don't use the terminology of skew. They simply say do not intersect. For example, over here, it says L and N intersect. So whatever equations that you have, first of all, write in the column vector form. This equation, write in the column vector form. Expand, 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 you get three equations. Expand, you get three equations. There is a common point of intersection between the two, solve simultaneously. So again, three equations, two unknowns. The third one is for checking. I took the red equation, I took the blue equation, I solve it simultaneously. I get values of S and T. So one of them is S, the other one is T, this is T, this is S. Check it in the remaining equation. If both sides are equal, that means S and T satisfies all three equations. Therefore, the lines intersect and we get a point of intersection. So sometimes they can only ask us, show that the lines intersect. That is what we are doing. Show that the lines do not intersect. That means this S and T won't satisfy all three equations. Such lines will be skew. If the lines intersect, to find the point of intersection, either plug in S in its equation or plug in T in its equation, place parameter where it belongs. Of course, you will get the same answer. If they ask for the coordinates, write it horizontally. If they ask for the position vector, write it vertically in column vector or in the IJK form. Read the question for this. Angle between the lines, angle between the direction vector, very simple. Now over here, let's apply this concept. It says the point P has position vector 1, 5, 6. Show that the perpendicular distance from P to the line AB is equals to root 3. So now what needs to be done? That is, you draw a small diagram. And before that, let's first find the equation of AB. So in some questions, that would be done in the first part. Over here, I have done this. That's the equation of line AB. Now that is what the diagram should look like to give you to give you an examiner a good understanding. I'm giving you that good understanding. You should give it to the examiner. So now over here, this is point P. This is the line. Let the foot of the perpendicular be R. So R, let's call it foot of perpendicular. If I get hold of the foot of perpendicular, then finding this vector and finding its magnitude, or find the distance between 2 points, it's the same thing. So now what we do is that the equation R lies on the line. So the position vector of R in terms of lambda is written. The next thing, find PR. Find PR, that is OR minus OP. That is this thing. Now this PR is perpendicular to the line. PR is perpendicular to direction vector. PR dot product with direction vector equals to 0. That is PR. That is direction vector equal to 0. So this was the direction vector. -1, 2, and 3. And then you find a value of lambda. Sometimes lambda comes out to be integers, sometimes fractions, sometimes a weird number like 7/20. It could happen. Positive, negative, it could happen. Plug value of lambda in PR. So I plug in the value of lambda in PR, I get this thing. Let's find the magnitude of PR, that is the perpendicular distance. Now I have changed the same question a bit. Find position vector of the foot of the perpendicular from P to the line AB. So now this is OR, the same thing again. This OR is written. And this is OR evaluated because I found the value of lambda is equals to 2. That goes in the foot of perpendicular. I'm not putting it in PR. I'm putting it in OR. So let me highlight this. So this value of lambda that goes in foot of the perpendicular. So now I'm interested in OR. That comes out to be 247. So over here, or 2i plus 4j plus 7k. Now, if they ask for the distance, the perpendicular distance, so I have R, I have P, I can use the distance formula, I can find it. Not an issue. Something like this. With respect to the origin, the points A and B have position vectors OA, OB. The line L has this equation. Find the acute angle between the direction of AB and L. So find AB, OB minus OA, and L. The direction vector is there. Again, it's scalar product. Now it says, find the position vector of the point on L such that AP is equals to BP. So this is OP. OP is a point on that line. AP in terms of lambda. BP in terms of lambda. That is AP. That is BP. So let me write over here. This is AP. And this one is BP. Now they are asking, the magnitudes are the same. They should have used a magnitude sign, but they haven't. So technically, this was this thing. This is magnitude of AP. Should be the same thing as magnitude of BP. And now the distance formula. Square both sides, lots of algebra. You find the value of lambda is 6. OP, plug this value over here, you get this thing. Something about this box thing. It says in the diagram, OABCDEFG is a cuboid in which OA is 2 units, OC is 3 units, this is 2 units. OC, it's not drawn to scale or it looks weird. This is 3 units. OD is 2 units. Unit vector IJK are parallel to OA, OC, OD respectively. So not only will they draw, they will also write it in paragraph. The point M on AB is such that MB is 2AM. So M is over here. MB is twice the length of AM. That means AM is 1/3 of AB. MB is 2/3 of this thing. Find the vector equation of a line through M and N. So now what needs to be done? MB is 2AM. AM is 1/3 AB. AM is 1/3 AB. AM is 1/3 of 3J, which is J. MB naturally is 2J. GN is I, that is NF. GN is I, and NF is also I because this whole thing is 2I. So now, once this thing is done, it says find the vector equation for the line through M and N, and then you can solve this thing. Just have a good look over here. Let me just minimize this thing, and so that you can have a look. So now, people, let's resume. So now it says vector equation of a line through M and N. OM, it's O till A, that is 2I, and A till M, that is over here J, or 210. MN, so start from M, go till N. So this is 2J, this is, I think, 3K, 2J, 2K, this is also 2K. This is 2, this is 2, this is -1. So this is 2, 2, -1. Okay, right in the proper order because it's IJK. Then position vector of P, the foot of the perpendicular, from D to the line through M and N. So this is the line that is over here. This is point is on the line, expand it. This is point D, 0, 0, 2. Find DP, which is OP minus OD. DP is perpendicular to line. DP dot product with direction vector equals to 0. You find lambda. Look at this value, strange value. OP, they're asking for what? They're asking for position vector of P, not the distance. So plug in OP, and then you get this thing. Something like using some area kind of thing. I was looking into that. Okay, I think that this, let me show you something from the recent past paper. I was just about making a video on that. And this thing is simple, nothing special. No, this is nothing special. Just looking for the green one. Yes, this is a nice one. Important question. The line L1 passes through the point 3, 1, -6, and it's parallel to this vector. Write down a vector equation for L1. This is the fixed point. Let me highlight it. 3, 1, -6. That's a fixed point. Parallel to the vector, that is 2, 1, 4. That goes over here. Now the second part is very nice. It says the line L2 passes through the point -1, 3, and 6. So this is -1, 3, and 6. That goes over here. And then it says it's perpendicular to the vector 3, -2, and 1. So this is 3, -2, and 1. Now, the direction vector for L2 has no component in the x direction. So now over here, this is 3, -2, 1. The direction vector, that means the direction vector has no component in x direction. This is 0, this is A, this is B. That means this direction vector over here, 0, A, and B, dot product with this thing over here, which is 3, 2, 1. 3, negative 2 and 1 should equal to 0. Now there is one equation with two unknowns. How can I solve it? So minus 2a plus b is equals to 0. B is 2a. The reason why we can solve it is that scalar multiples are direction vectors. They are scalar multiples of one another. So b is equals to 2a. If a is 1, b is 2. If a is 2, b is 4. If a is negative 3, b is negative 6. So I chose the easy one, that is 1 and 2. So let me choose this one. That is this one. This is 2. So I wrote 1. I wrote 2 over here. That's how I get this thing. So this was a very nice concept that they asked for this. Very out of the box. Calculate the acute angle. That is the basic thing. I think that is all good about vectors. Let's talk about numerical solution. Numerical solution of equation for equations which don't have a solution the normal way. Just a brief overview of things that we have done related to P1, P3, and then O-level maths. That is about equation of a line. Gradient positive, and y-intercept is positive, y-intercept is negative. Similarly, negative gradient, positive y-intercept, negative y-intercept. Line parallel to x-axis, gradient is 0. Line parallel to y-axis, gradient is undefined. This is of the form y is equals to a constant. This is of the form x is equals to a constant. Power functions, exponential functions, y is equals to a raised to power of x. Y is equals to a raised to power of x with a minus on the outside, reflection in x-axis. You have studied P1. Y is equals to a raised to power of negative x. This is a graph of decay. This is a graph of growth. This red and this thing, they are reflection of each other in the y-axis. This is growth. This is decay. If you put a minus on the outside, that again is a reflection in the x-axis. Y is equals to e raised to power of x, e raised to power of x plus 1. The asymptotes also go up. Y is equals to e raised to power of x versus e raised to power of 2x. They both pass through the same y-intercept, same asymptote, but this one is steeper. Y is equals to 2e power x. This is passing through the y-intercept 2, but the asymptote is the same. Ex and ln x, they are reflection of each other in the line y is equals to x. How do you draw the graph of ln x? This was asked in this, I think, October, November 2025 in one of the numerical solution question. Y is equals to ln x. Two things are necessary. In order to find the domain, x is greater than 0. In order to find the x-intercept, whatever is over here equal to 1. More examples on this. Y is equals to ln 1 plus 2x. 1 plus 2x is greater than 0. X is greater than negative half. So draw a line negative half, and it should be to the right of that line. And then x-intercept, that is 1 plus 2x equals to 1. X is equals to 0. So this is like this, but it has been shifted. Y is equals to ln 3 minus 5x. 3 minus 5x is greater than 0. X is lesser than 3/5. So now draw the line x is 3/5. It's lesser than that to the left of this. And the y-intercept and the x-intercept is 2/5. So now the shape is turned. Reciprocal graphs, y is equals to k over x, first quadrant, third quadrant, there is a horizontal asymptote, there is a vertical asymptote. Y is equals to k over x squared, first quadrant, second quadrant, horizontal asymptote, vertical asymptote, there are no intercepts, no intercepts. Minus on the outside, reflection in x-axis. Minus on the outside, reflection in x-axis. Quadratic, you know it. Shift up, shift down, factorized form, completed square form, everything. Cubic function, if the coefficient of x cube is positive, it starts from top right, goes till bottom left. If the coefficient of x cube is negative, top left till bottom right. If the cubic is in this format, it also has to pass through the roots. If a cubic is of this format in which one of the bracket has a square in it, not only it's a root, it's also a turning point. Otherwise, the turning points are different, the roots are different. But in this scenario, the root and turning point is the same. Yes, you should know trigonometry. Y is equals to sine x. The reciprocal of sine is cosec x. So now let me focus on this thing. That is y is equals to cosec x. Draw the sign, flip it up. This thing, it's between these two asymptotes. Because sine of 0 degree is 0, but cosec of 0 degrees is 1 over 0, which is undefined. Same goes for 180, same goes for 360. This pink one, that is cosec. This pink one, that is cosec. Over here, that is sec. This one between negative 90 and 90. Between 90 and 270, it goes down. Tangent x between two asymptotes, negative 90, positive 90. Cot x between two asymptotes, 0 and 180. The asymptotes have shifted. Why? Because tangent of 0 is 0. Therefore, cot of 0 is undefined. Tangent of 90 is undefined. Cot of 90 is 1 over undefined, which is 0. So this is negative 90, 90, 270, and so on. This is 0, 180, 360, and so on. Now, numerical solution of equation, the basic idea is this. That is, there are two things. The first thing is the examiner will ask you to draw two sketches, and the number of intersection are the number of the roots, because originally it was one equation such as this. X equals to 1. Now, I don't know how to solve this. So either I can let x remains as it is and 1 over